Hello class, good morning. Our topic for today is understanding space or solid figures. So, when you say solid figure or a space, a three-dimensional shape or solid has length, width, and height. When you put together plane figures in such a way that you will share some common edges, you create a space figure. For example, we have a plane or square plane figures, six square plane figures. If we're going to connect this for a six square plane figures, we can create a space figure. So what is the difference of space figure to solid figure? It means, if a space figure, it means that there is a space inside that given figure, while solid figure, intact, no space. A rectangular prism has three pairs of parallel faces, 12 edges, and 8 corners or vertices. There are 6 rectangles that form the given rectangular prism. So this is an example of space figure. So first is the front face. So the front face is A, B, C, D, or we can say that um, square A, B, C, D, because this is a rectangle A, B, C, D. So this one, A, B, C, D, this is the front face. Next is the back face of the rectangular prism, E, F, G, H. This one is the back face of the rectangular prism. The top face is this one, top, E or A, D, H, E. And the bottom face is this, B, C, G, F. B, C, G, F, bottom face. Left face. So the left face is A, B, F, E. This one is the left face, and the right face is while the right face is D, C, G, H. So this is the right face. Next is two adjacent faces have common segment known as edge. So segment AB is the common edge of face ACD. So this one, and ABFE. So their common edge is AB. So I will repeat, rectangle ABCD. So this, the front face, and the left face, which is IBFE. So they share a common edge that connects the two faces, which is the segment AB. So this one are what we call common edge, AB. Okay. Segment, again segment, these are what we call segment, EH, DH, HG, GC. So when you talk about vertices, since we said that there are 8 corners or vertices, so these are the vertices A, B, C, D, E, F, G, H. The corners are the vertices of the given space figure or solid figure. So these are examples of space figure and solid figure. So they are both rectangular prism, but you can see this one is a solid figure and this one is a space figure because there is a space on this part. So space figure, solid figure. Anyway, space figure and solid figure are both three-dimensional objects or shapes. Next is a polyhedron, is a space or a solid figure that made up of polygonal regions. When you say polygonal regions, okay, these are triangles, square, rectangles. Circle are not polygonal regions. So any solid figure that has curved surface is not a polyhedron. Any solid figures or space that has curved surface is not a polyhedron because polyhedron is is made up of polygonal regions and a circle is not a polygon. This means that the faces of the polyhedrons are regions formed by triangles, squares, rectangles, etc. The faces of a polyhedron are flat and the edges are straight, no curved lines or circle. So, first example of a polyhedron is a prism. A prism is a polyhedron with at least a pair of parallel faces. This is a characteristic of a prism. It has a pair of parallel faces. So, a rectangular prism has 12 edges, 3 pairs of parallel faces, and 8 vertices. When you say parallel faces, these two faces will never meet. For example, the top face and the bottom face of a rectangular prism, they will not meet. Next is the left, and right. It will never meet. And the front and back. So there are 3 pairs of parallel faces in a rectangular prism. Next is let's proceed to triangular prism. So the triangular prism has 9 edges. 2, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these lines are what we call edges. 6 vertices, 1 corners, 1, 2, 3, 4, 5, 6, and 1 pair of parallel faces. So what is that parallel faces in a triangular prism? The top and the bottom face. That those are only the parallel faces in triangular prism because this side, okay, this one, and this one, okay, these faces will meet in this edge. That's why we cannot call this as parallel faces. The same in this part. So only this triangle, okay, the triangle are the pair of parallel faces. So that is triangular prism. Next, proceed to cube. So it is a special rectangular prism that has 6 congruent faces. It means that the sides of or the length or the faces of the cube are the same. the same in size. So 6 equal or 6 congruent faces, and it means that a cube also has it has 3 pairs of parallel faces, 12 edges, and 8 corners, the same with rectangular prism. The only difference is cube has 6 congruent faces. So let's proceed to two triangular. Okay, this one is triangular prism. First, let's identify the two triangular faces. So the two triangular faces of this rectangular prism is ABC, triangle ABC, and triangle DEF. Okay, these are the triangular faces of the rectangular prism. Next is the three rectangular faces, that is ADFC, ADEB, or ABED, then BCFE. So those are the three rectangular faces of this triangular prism. This one is a triangular prism. Next, it has 9 edges. So what are those edges? Segment AB, segment BC, segment AC, segment DE, segment EF, segment DF, segment BE, segment CF, and segment AD. Those are the edges where the two faces meet. Next is the vertices. We have A, B, C, D, E, F, or the corners. We have 6 corners, 6 vertices. It has one pair of parallel faces. Okay, only the triangular faces. So ABC is parallel to DEF. So next is pyramid. So a pyramid is a polyhedron without any parallel faces. The shape of the base of the pyramid determines its names. A rectangular pyramid has 8 edges, 5 vertices, and rectangular base. That's why we call it rectangular pyramid. While a triangular pyramid has 6 edges, 4 vertices, and a triangular base. So these are different types of pyramid. So rectangular because its base is rectangle, triangular because its base is triangle, pentagon pyramid because its base is a pentagon. So next is a pentagonal pyramid. So let's identify the faces, edges, and vertices. Let's start with the triangular faces. So first is APB. Okay, this one APB, triangle APB, triangle BPC. That's 2. Triangle CPD, CPD. 3. Triangle PDE, PDE. Okay, this. And triangle EPA, EPA. So these are the 5 triangular faces of a pentagonal pyramid. Okay, 5 triangular faces because it is a pentagonal pyramid. If it is a rectangular pyramid, then it has 4 triangular faces. For the triangular pyramid, 3 triangular faces. Next is one pentagonal face, which is pentag pentagon A, B, C, D, E. Let's proceed to segments or the 10 segments in a pentagonal pyramid. First is okay, AB, BC, CD, DE, AE. So that's the segment, okay, on the base. We have 5 on the base. And next is another is AP, EP, DP, CP, and BP. So in total, we have 10 edges. And next is how many vertices, or what are the vertices? A, B, C, D, E, and P. Those are the vertices of the pentagonal pyramid. So, as I've said a while ago that polyhedrons, okay, are made of polygonal regions and circles are not polygon. So, since these solid figures, okay, are made of circle and it has curve, then we can say that these are not polyhedrons. Okay, curve, curves, curve. Okay, but these are still solid or space figures. So cylinder, it has two circular base and a curved surface. The curved surface is like a road rectangular regions. So two circles, and this one, okay, the body is a rectangle. If you curve a rectangle, then you can achieve this circular body. Next is sphere, has a curved surface without a base. All the points on the curved surface are equidistant from the center of the figure. It means that if this is the center, all the points from the circle are equidistant, so equal in distance from this or from the middle of the sphere. And next is cone, has a circular base and a curved surface. So circular base and a curved surface. Okay, this is curved, but it looks like a triangle in a drawing. For your activity, answer practice A, B, and C on page 291. Take a photo of your answer and send it via private message. Deadline January 26.